Today we will define similar triangles, learn about the three triangle similarity theorems, and apply the three theorems to determine if two triangles being compared are similar. Let's begin. In geometry, two shapes are similar if they are the same shape but different sizes. For example, you could have a square with sides that are 21 centimeters and a square with sides that are 14 centimeters. They would be similar. But if you compare one of those squares to an equilateral triangle, they are not similar because they are different shapes. Similar triangles are easy to identify because you can apply three theorems specific to triangles, known as angle-angle, side-angle-side, and side-side-side. First, you must know that the three theorems for similarity in triangles depend upon corresponding angles. In geometry, correspondence means that a particular part on one polygon relates exactly to a similarly positioned part on another. If two triangles are oriented differently from each other, but you can rotate them to orient them in the same way and see that their angles are alike, you can say those angles correspond, or that they are corresponding angles. You also need to know about the included angle. This is the angle between two pairs of corresponding sides. You cannot compare two sides of two triangles and then leap over to an angle that is not between those two sides. Here are two congruent triangles. To make your life easy, we made them both equilateral triangles. Triangle FOX is compared to triangle HEN. Notice that side FO is congruent to side HE. Side OX is congruent to side EN, and angle O and angle E are the included congruent angles. The two equilateral triangles are the same size, so they are actually identical triangles. Now, if side EN of triangle HEN was twice as long as side HE, they would be similar triangles. Next, let's talk about the three triangle similarity theorems and test them out. First, we have angle-angle, which says that two triangles are similar if they have two pairs of corresponding angles that are congruent. For angle-angle theorem, all you must do is compare two pairs of corresponding angles. Here are two scalene triangles, triangle JAM and triangle OUT. We have already marked two of each triangle's interior angles with the geometer's shorthand for congruence, the little slash marks. A single slash for interior angle A and the same single slash for interior angle U mean they are congruent. Notice angle M is congruent to angle T because they each have two little slash marks. Since angle A is congruent to angle U and angle M is congruent to angle T, we now have two pairs of congruent angles, so the angle-angle theorem says these two triangles are similar. The second theorem requires an exact order: a side, then the included angle, then the next side. The side-angle-side theorem states if two sides of one triangle are proportional to two corresponding sides of another triangle, and their corresponding included angles are congruent, the two triangles are similar. Here are two triangles, side by side and oriented in the same way. Triangle RAP and triangle EMO both have identified sides, measuring 37 inches on triangle RAP and 111 inches on triangle EMO, and also sides 17 inches on triangle RAP and 51 inches on triangle EMO. Notice that the angle between the identified measured sides is the same on both triangles, 47 degrees. Is the ratio 37 by 111 the same as the ratio 17 by 51? Yes, the two ratios are proportional, since they each simplify to 1 by 3 or 1/3. With their included angle the same, these two triangles are similar. The last theorem is side-side-side. This theorem states that if two triangles have proportional sides, they are similar. Here are two triangles, triangle FLO and triangle HIT. Notice we have not identified the interior angles, we only have the sides. The sides of triangle FLO measure 15, 20, and 25 centimeters in length. The sides of triangle HIT measure 30, 40, and 50 centimeters in length. You need to set up ratios of corresponding sides and evaluate them. Here is what that looks like. 15 divided by 30 equals 1/2. 20 divided by 40 equals 1/2. And 25 divided by 50 also equals 1/2. They are all the same ratio when simplified, 1/2 or 1 divided by 2. So even without knowing the interior angles, we know these two triangles are similar because their sides are proportional to each other. Now you know what similar triangles are and 3 theorems you can use to identify similar triangles.